Hi all, my name is Marco Mancini and I am a cloud technical evangelist at OpenNebula. I would like to thank the organizers and for this opportunity and for this talk. Today I will speak about provisioning and managing infrastructure resources to deploy multiplayer game servers on the edge. The point is that in order to satisfy low latency requirements for multiplayer games, it is necessary to deploy resources, game servers, that are geographically in close proximity to the gamers. We will look at OpenNebula edge computing features and also at the recent integration of Firecracker and Docker Hub for orchestrating containers. And we are going to deploy and manage Kubernetes clusters based on K3s, the lightweight distribution built for IoT and the edge by Ranger. And then on top of Kubernetes cluster, on the edge, we can deploy the Agones open source platform for multiplayer games and game servers. So first, let me introduce briefly OpenNebula. OpenNebula is a simple open source solution to build and manage enterprise clouds that combines existing virtualization technologies with advanced features for multi-tenancy, automatic provision, and elasticity, in order to offer on-demand virtualized services and applications. OpenNebula integrates multiple types of virtualization technologies to meet different workloads needs. So integrates VMware and KVM virtual machine for fully virtualized clouds, LXD system containers, and Firecracker micro VMs for serverless deployments. OpenNebula provides Sandstone, that is a graphical user interface for both end users and administrator, and simplifies the management of all OpenNebula resources and operations on them. OpenNebula is integrated with third-party tools like Terraform, Docker Hub, Ansible, and Kubernetes. How is OpenNebula used? OpenNebula gives the opportunity to build a true hybrid and multi-cloud platform by combining edge, public, hosted, and private cloud operations. So it helps organizations to easily embrace hybrid and edge computing, allowing them to grow their enterprise cloud on demand, so with infrastructure resources from third-party public cloud and bare metal providers such as Amazon Web Service, Microsoft Azure, and Equinix Metal. So OpenNebula provides one uniform environment that allows to manage and perform operations on resources that are on-premise, hosted, or on the edge. And then, by providing a marketplace with pre-built appliance and also the recent Docker Hub integration as a marketplace, OpenNebula will facilitate the deployment and management of applications that can run on any infrastructure, can be on-premise or on the edge, and can be appliances based on virtual machine or containerized applications as a micro VM. So let me introduce OneEdge, that is an OpenNebula project and initiative supported by the European Commission under the Horizon 2020 program. And this initiative is developing innovative features, and the objective is to create the first open source edge computing platform to bring private cloud computing to the edge. So you can also check the website oneedge.io for further information. And this project is built on OpenNebula. So in our path to expand open source cloud computing to the edge, we take an opportunistic approach for node provisioning. By taking advantage of already available resources that are offered by third-party bare metal providers, such as I said, Amazon Web Service, Equinix Metal, and Microsoft Azure. We are also part of Gaia X project, that is a federated cloud infrastructure in Europe, and we are going to incorporate also those resources in the provider edge catalog that will be a feature for next year. So in this way, companies can easily create and manage their own edge environments and without having to provide or own those underlying resources. So once the edge physical node for existing bare metal cloud providers are provisioned, OpenNebula will allow to deploy in software form the other infrastructure components that are needed on the edge. so such as software-defined networking, virtual network functions, software-defined storage, and finally virtual machine and containerized application. Now, in order to deploy a fully operational OpenNebula cluster in a remote provider, we have built a tool, one provision, and each new provision is described by template, a YAML document that specifies the OpenNebula resources to add. So clusters, hosts, data stores, virtual networks, so physical resources to provision from the remote infrastructure provider. Then you can also specify the connection parameters, for example, for SSH, and the configuration steps as a playbook. And then once the template is prepared, it will be validated and will be used to create a new OpenNebula cluster as a remote provider resources. Okay, now let's move how containers are managed within OpenNebula. So OpenNebula provides different ways to integrate containerized application. First, OpenNebula provides the Kubernetes appliance that is available from the OpenNebula marketplace, where you can create and deploy Kubernetes cluster. Every node is then managed by OpenNebula as a regular virtual machine, but OpenNebula doesn't manage containers or pods inside the Kubernetes cluster. And the Kubernetes cluster just exposes the Kubernetes API, so then you can access via kubectl or with a dashboard. But you can use also the OpenNebula Docker machine driver for creating Kubernetes cluster by using Ranger UI. And using Ranger, you can create pools of nodes based on a node template that defines the parameters used to launch nodes in OpenNebula. Recently, with the latest release Firework, OpenNebula now provides a native model for the management and orchestration of containerized application. And this is based on the integration on Firecracker and Docker Hub. So OpenNebula approach is going to integrate a Docker Hub as a new native marketplace, so that provides the user with immediate access to Docker image. So through this integration, Docker images can be easily imported into an OpenNebula cloud, following a process that is similar to the way in which the OpenNebula public marketplace operates for the appliances. And the OpenNebula context packages are installed during this import process. So once the image is imported, it becomes fully functional. So including auto IP configuration, SSH key management, and for example, custom init script. So regarding Firecracker and this integration that is in the latest release of OpenNebula, so Firecracker is an open source virtualization technology that has been developed by Amazon Web Services that use KVM to launch lightweight virtual machines, so-called micro VMs. So to have enhanced security, workload isolation, and resource efficiency. So it is widely used by Amazon Web Services as part of Fargate and Lambda services. And you can quickly deploy applications as containers by using Firecracker in OpenNebula while keeping them in secure isolation. And now with this integration, OpenNebula provides now an innovative solution to the classic dilemma between using containers that are lighter but with weaker security, or virtual machine with strong security but high overhead. Now Firecracker is seamlessly integrated with the network stack, the storage provided by OpenNebula. You can also create, so now you can create, build, and manage a secure, self-service, multi-tenant cloud based on Firecracker micro VMs for serverless computing. And also you can use any technology, any stack in OpenNebula, like for example OneFlow, that allow you to define and manage multi-VM applications as single entities, as a single services. And then with one flow, you can define dependencies, you can define auto-scaling policies for the application components. And that's why we can, thanks to this integration of a Firecracker and Docker Hub, now the idea is to deploy, manage, and orchestrate Kubernetes clusters based on K3s as an alternative to the appliance that is already provided by OpenNebula that is based on a virtual machine. So by using a K3s Docker image within Firecracker micro VMs, and by using one flow service, we can deploy and orchestrate K3s clusters with the server and the agent component on the edge or on premise, on any infrastructure that that we are using in OpenNebula. So what is next for today? So we will show now a demo about these technologies, and we will start from an OpenNebula deployment with a central location that has only the front-end component, one flow and one gate that are already deployed. So the first step is going to show how to provision edge resources on Equinix Metal on the Amsterdam facilities. Then we will show how to import the K3s image from Docker Hub, define Firecracker micro VM templates, and define one flow services in order to deploy and orchestrate K3s clusters on the edge. And then we are going to deploy Agones, that is an open source platform developed by Google in collaboration with Ubisoft on top of the distributed platform Kubernetes. And after we deployed the Agones platform, we can proceed to deploy a game server for the Xonotic game, that is an open source first-person shooter game, and we will connect it with the client. So now let's start with the demo. So first of all, let me show you the dashboard of Sunstone, so the graphical user interface of OpenNebula. As you can see, we don't have defined any host, virtual networks, and so on. So here we just deployed the front end with the Sunstone. Now, first, let's provision some resources on the edge by using a packet, now Equinix Metal, bare metal provider. So we are going to use the one provision tool. So here we can see that we don't have any cluster host defined. And then I have prepared a template. So we are going to use one provision, the create command, in order to provision resources on Equinix Metal. So this will take 5-10 minutes to provision hosts and clusters. So while it's doing the deployment, let me show you the template. So here we are going to use a playbook for Firecracker, since the host that we are going to provision will use the Firecracker virtualization technologies to instantiate micro VMs. Here we specify the driver for packet, Equinix. Then you have to specify the project ID and the token ID, the facilities. As I said, we are going to deploy on Amsterdam facilities, MS1. So we can specify the type of instance and the operating system of the host. Then we are going to deploy 3 data stores. The default one will be used for the Docker images that will be imported in OpenNebula from Docker Hub. Then we have the system data store that is used for instantiating the micro VM, and the files data store that will be used to import the kernel that is needed for Firecracker. Then we define a couple of networks, one private network and one public network. The public one will be IP from packet that will, and we will use this driver to map the traffic that comes from internet to the internal private networks and the private IP that has been assigned to the micro VM. Okay, now let's go back to the Sandstorm. So here we see that a new cluster has been defined and a host is being provisioned. So if you look at the data store, 3 new data store has been defined. And now let's import the Docker image in the default data store for the edge node on Amsterdam facility. So we select the data store, and here we have to provide a Docker URL for the image. In this case, I'm using a custom image for Ranger K3s, since this image will be enhanced with the contextualization package of OpenNebula in order to assign the IP, for example, to the micro VM. So we have to build a custom one, since the original one is not working with the contextualization package, but we are looking into this. And then we can import in the files also the kernel that will be used by Firecracker. And this kernel has been compiled with the VXLAN enabled in the kernel. Okay. So we have to select the data store, and then we can create this. Okay. Once the 2 image has been defined, let's look at the templates for the micro VM. So for the server, we have defined a template where we can specify the memory, the number of CPU, and then we can we can specify the image, that is the Docker image, that it will be imported. We can specify the networks, the private and the public as an alias for the private network. In the section OS and CPU, we have to specify some boot parameters for the kernel and the kernel that we are going to use. Finally, in the context section, here there is the start script for the server, and I will explain this in a few moments. And then we set also some custom vars, for example, the host name to the K3s server. So let's look also at the agent. So also in this case, we define the memory, the CPU, number of CPU, and then we set as a disk the image that is imported in the default, the Docker image that is being imported. Also in this case, we can define 2 networks for the micro VM. And in this section, as always, the boot parameters and the kernel. In the context, there is another start script. This is different from the server, and I will show you in a bit. And in this case, the host name is set to K3s agent, but we will use also the ID of the VM that is being assigned, that will be assigned when the micro VM is instantiated. So in order to have a different host name when we deploy a cluster of K3s. So once we have defined the 2 templates, one for the server and the other for the agent, we can use one flow to define a service for deploying a cluster. So let's call this service K3s cluster. So we define here the roles. So a role for the server, and we associate the template that we have defined. And then we have a role for the agent with its own template. Now, in this case, the agent will be deployed when the server will be running. Okay, so we have to check this parent role. And in order for to know when the VM is running, in the sense that, for example, the application is started, we will use this ready for one gate. So one gate is the metadata server of OpenNebula. So now let me first So once we create this cluster, we can instantiate. We can create the cluster, and now the cluster will be in a deploying state. Okay? So this is now to instantiate, to deploy first the server, as we said, and then when the server is ready, is going to deploy also the agent. So these are going to be deployed on the host. That meanwhile we can see that one provision has finished the deployment. So now we have this cluster. So now the server and the agent will be deployed on these resources. Okay, so let me show the scripts for the server and the agent. So we are use one gate. So that now the service will get some. We need some minutes in order to run. So I will explain the start script of the server and the agent. So the server will use one gate. As I said, is the metadata server OpenNebula to get the private IP and the external IP, so the public IP. So this will be used to set the options, node IP, external IP, and that one for the certificates. And then we can run the K3s server. And once the K3 server is run, is executed, we are going to wait for the token to be available. Once the token is available, what happens is that we use one gate to update the metadata of the server micro VM by putting this key, K3s token, to the value of the token that is contained in the file. And then after we do this, we say to one gate that this VM is ready, this micro VM is ready. And so one flow will use this information then to start the deployment of the agent that that will be deployed when the server is ready. So if we look at the script of the agent, in this case we use one gate to get the server ID and the token from the server and the IP, so we can set the option for the server and we can set the option for the token, and then we get also the private IP and the public IP that has been assigned to the micro VM, and we can set the K3s options. And we can call the agent, and then we just say that also this VM is running. So let's go back to the Sandstone and let's see what is the status. So here we can see that the server is in running, and also the agent is going to be deployed. That means that the server is set ready equal to yes to one gate. So now let's get the configuration file for K3s. And first let's check the public IP of the server. So let's copy the configuration file for to use kubectl. Okay. So first of all, we have to change also the public IP, the IP, sorry, in the configuration file, and now we can export the kubeconfig. Now we can use kubectl. And here we can see that the server is ready and its internal external IP has been set. So let's see for the agent. So let's see. Okay, now the agent also is running. So we need also some to be ready, I think. So let's see. Yeah, you see also it got the local IP and and the private IP and the public IP. So let's see if, okay, so now is going to be deployed, so it's connect, so we can see the private and the public IP. Now, in order to proceed, we can install Agones to this cluster. So let's create first the namespace, and then we will we'll install Agones. So let's check if these are running and creating, and then we can deploy the game server. Okay, so we're going to deploy the Xonotic game server, and we can check if the game server is going to be scheduled. Okay, so this will take a few minutes because he has to pull the image since it's not in the node. Meanwhile, I can show you, for example, how to use the scaling of one flow. So if we go on the service and we would like to deploy more agents, we can, as I said, we can use some elastic policies based on performance metrics, or we can also do manually. So let's say we would like to have another agent. So here we can set the number of micro VMs that we would like to have, and we use scale. And now what is going to happen is that this will change in a scaling state, and also the state of the service will change to be scaling. And here you can see that another agent is going to be deployed. Okay. So let's see if the the game server now is ready. So what we can do now is running the Xonotic game client, and then we add the address and the port. So here, now we can add the address, this one. And then the port. And here the client now is starting, and also the game is loading. And now you can see that we are now playing on this game server of Xonotic. Okay, so let me get out of the game, and here is still deploying. It's still deploying, and now it's running. So then you can scale. You can also decrease when the service is also again in the now is in the cooldown state. So when it will go in the running state, you can perform another scaling operation. So this is for the demo. Now let's go back to the presentation. So other few things. So you can look at several resources. So we have a screencast, articles, and a new white paper about age with OpenNebula. Also, if you want to try OpenNebula, there is mini one that allow you to easily install a single node with LXD, KVM, or Firecracker, but also to deploy resources on the edge on Equinix Metal very easily. So it's a very nice tool for evaluation. And then you can try the latest release, a Firework, that integrate Firecracker with Docker Hub. Thanks for your attention. These are our contacts, so you can write us, you can visit our website, our forum, and keep in touch with us. Now, if you have any question, I will answer to them. Thank you.